This is a production of Cornell University.
So, the title of my talk is Modeling Street Trees on a Statewide Basis in New York State, but essentially what I'm doing is it's a state of the state of street trees in New York State. It's a statewide assessment of street trees. And just to define what a street tree is, it's a tree growing in the public right-of-way for the benefit of the community. That's how I'm defining it. And public right-of-way typically is, most often, is a tree lawn like this between the sidewalk and the street. Now, when you say for the benefit of the public, that wasn't originally what street trees were about. They were basically for the amusement and pleasure of the noble classes in Paris. That's where. But the American model is far more democratic, at least in theory. And they're just, it's something you see everywhere. It's a fixture in everyday life. Although, when we don't see them, we go, gee, what's wrong with this neighborhood in Lima as compared to this? And we associate street trees in many ways with the aesthetics of the community, the identity of the community. But increasingly, what we'd like to think about is the benefits and ecosystem services associated with street trees, which is something I'm very concerned with, not only in my work here, but with my work for Sustainable Sites Initiative in Austin, Texas. And so ecosystem services can include stormwater reduction, air quality improvement, energy conservation, and so on. And they're basically proportional to the amount of leaf surface area associated with the tree. So here you can see droplets of precipitation intercepted by this leaf. Now, the Forest Service has gotten very interested in conceptualizing, thinking about large landscape scale urban forestry and canopy cover. And they've invested a lot of time and money in canopy cover assessments at this landscape scale. And what they ask two questions basically. How much tree canopy do I have? And associated with that, how many ecosystem benefits do I have associated with that? And how much tree canopy could I have? How many planting spaces, in a way, are available? Which is good. I mean, this is a very useful way to look at what exists and what you could have, but it doesn't answer a fundamental question at a much more discrete scale, which is what tree species should I plant? Remote sensing, hypospectral remote sensing is not all that reliable in terms of identifying tree species. So it also doesn't answer a larger question, such as how many ash trees are vulnerable to the emerald ash borer. And as you know, the emerald ash borer is an invasive pest species that is killing ash trees. And there's also the Asian longhorn beetle, which is killing maple trees. So these are issues at a larger than local scale, a statewide scale, that are of concern to people like the New York State Department of Environmental Conservation. And the work I've done is really targeted towards answering these types of questions. Now, when I say scale or level, we typically collect data at a very discrete scale, and then we aggregate it to the scale of the village, for instance, and write a report. But there are other wider, larger scales as well. And New York State is really, what I'm basically doing is extrapolating from this scale of the village or the municipality to that of the state. And as you can see, when you start extrapolating, when you start getting into a larger scale, you sort of lose a lot of your resolution. You lose some of the detail associated with that data. It's a trade-off. So my goals in conducting this assessment, and basically I was working with the DEC, and some of these are stipulated by them. But basically, I wanted to identify the prevalent, the most common street tree species and genera in New York State. I wanted to estimate the numbers for those prevalent street tree species and genera. and I want to estimate the annual benefits provided by street trees as calculated by the U.S. Forest Service has a program called iTree. And some people love it, some people don't. The DEC asked me to do it using that program, so that's what I did. But it quantifies in monetary terms ecosystem and other benefits such as energy conservation, property value, and stormwater reduction. And to do all these three goals, I wanted to use methods that were easily replicable by other states, because the issues that are faced by New York State are faced by other states as well. And the idea is that whatever is done here could be exported to those states potentially. So how is this assessment different? Well, I should say that the idea of a statewide assessment has been contemplated elsewhere as well. California has periodically sent questionnaires out to urban foresters and gotten feedback from them. Washington State would like to do something like this, but they cut the funding for it, so they didn't do it. There are some studies as well as Indiana and South Dakota. However, what they don't do is they don't basically construct a statistically valid model, and that model is not, and their data isn't necessarily based on street tree inventory data, and they don't identify and incorporate geographical differences into their analysis, and they certainly don't use GIS in their analysis and statistical estimates. Now, essentially what I had to work with and had to collect was data from these municipalities. I got data from 138 municipalities. I subdivided New York City, where you have 5 boroughs, and each borough is a county, into its different boroughs. So I had 142 data sets. The data that we collect, that is collected in street tree inventories, is species, diameter, which is a proxy for the age of the tree diameter, and also it's very important is the planting site type, whether it's in a tree lawn or a front yard or a sidewalk pit, or whether you have utility wires overhead. The other side of this equation is that most communities in New York State don't have street tree inventories. And another issue which is actually as important is the fact that the data that is collected is typically all over the place. It's not necessarily standardized. I mean, I have maybe 6 or 7 different types of tree diameter type data, and the trick is to put it together, to aggregate it as well as I can, which isn't always possible. But, and also, not everybody collects tree genus, tree species. They'll collect genus but not species. So it's a bit of I wouldn't call it a mess, but there's certainly some challenges involved in the data. Now, one thing that was hypothesized early on and which proved accurate was that the data, the United States USDA plant hardiness zones, of which there are actually 5, I aggregated number 3 and number 4 because in the Adirondacks there are not that many populated communities, but that these zones had the most explanatory power of any variable I've found. And just getting into a discussion of these plant hardiness zones is another topic unto itself. And supposedly they're going to be updated next year, and if they do, then this will all have to be redone, which is fine. But that's what I went with, the 1990 zones. And in GIS, I aggregated my data into those respective zones. And what you'll see as I go through what I did is that means for variables of interest. Now these basically, so if I want to know, these were the constructs I used to sort of go to construct my analysis. And if I want to know the total number of street trees per species or genus, or the total benefits for all street trees, I first have to know how many, or I have to estimate how many street trees there are in New York State, which is a bit of a problem. But to figure that out, or to create an estimate for that, I said, well, the number of street trees is going to be a function of street length in populated places. Now, what do I mean by populated places? Populated places would be census places such as villages and cities, but it's also census blocks with a persons per square mile of greater than 500 people, which is the census threshold for suburban versus rural. And I said, well, these are streets that we can expect to contain street trees. So then I had to figure out the length of such streets. And just to give you an idea, what we're looking at is we're not looking for street trees on interstates. We're not looking for them in driveways. We're looking for them in residential areas. We're looking for them in commercial areas, such as those. And we can do this in GIS. We can differentiate between types of streets. And for instance, here we have the outline for the city of Syracuse, and we have in pink what I'm terming streets expected to contain street trees, as opposed to interstates and driveways and roads going through shopping malls and things like that, which are mapped, but we don't want to include. Now, it's also important to note that, we have villages outside here. We have census blocks with greater than 500 people. So those are also included in the analysis. I did this for all of New York State. And when you do that for all of New York State, you basically find, so here we have, these are not all the streets in New York State. These are the streets that I've differentiated in GIS. And each street has a length associated with it, which you can sum the length of. And so I came up with a measure for all of these streets expected to contain street trees in New York State of approximately 83 million meters, which is an estimate. It's not exact. And then I aggregated that data, those streets, to their respective plant hardiness zones. So I have 4 zones with a sum of street length in each zone. And the reason this is important is because the further south you go, let's say if you go from, you find an increasing number of streets in populated areas. So that's important because I used the relative length, summed length of streets in New York State by zone to create weights for most of my subsequent measures. So in other words, when you get to Westchester and New York City and Suffolk and Nassau counties, you have more street length associated with populated places than, for instance, you would up in the North Country. So here's my original construct, and if I plug in my meters for New York State, then I have to figure out what is my number of street trees per unit street length, which is the next thing I worked on. Now, as I said, I have 142 data sets and basically did the same thing for all of those. And basically, here's the boundary of a village, Lima, New York, in Livingston County. And because there's an inventory, I know how many street trees there are. I know what the length of the road is in Lima, and I can calculate a measure for street trees per meter or street trees per mile. What's interesting is that the group mean for this measure for 4 zones varies. So it's statistically different depending upon the zone. So for instance, in zone 7, you have a greater number of street trees per mile than you do in Lima, which I believe is zone 6. So statewide, you weight the group mean. I come up with a weighted statewide mean for this measure, and the weighted statewide mean for this measure is 0.500, and it goes on and on and on, street trees per meter. So I take that measure and I plug it back into my little construct here, and I come up with a number, an estimate of over 4 million street trees in New York State. Now, there's also a standard error of the weighted statewide mean associated with this. So I can create a 90% confidence interval for how many trees are likely, street trees are likely to be throughout New York State. So I've gotten this far, and so okay, back to figuring out the mean percentage of street trees or species. That's what I have to figure out next. Now for each inventory where I can do this, this is what a typical inventory looks like. We have the number of trees, you have the percentage of a particular genus in this case. Maple is heavily represented, which is not unusual in New York State. Basically, I take each inventory percentage, I create a mean inventory percentage by zone, and then I take my weights that you saw before, and I weight that to create a weighted statewide percentage for each genera and species. And if we look at, these are the 5 most prevalent street tree genera in New York State, and it's interesting that they seem, in most cases, they vary geographically. We can see, for instance, that Acer maple is is less prevalent down in Zone 7, which is Westchester, Suffolk, Nassau County, New York City. Conversely, we see more prevalent plantings of Quercus, which is oak, plane tree, Pyrus, whereas Gladitsia is pretty evenly distributed. Similar street tree species. This is kind of interesting how Norway maple spikes way up here, and it's also interesting to note that the 4 of the 5 most prevalent species happen to be maple. But again, we can see, sort of geographic difference in prevalence. So I go through all the data, I construct these, I come up with these statewide means for each species. I have confidence intervals, 90% confidence intervals. I do the same thing for genera. I do it for species. In this case, Acer platanoides, Norway maple is the most prevalent street tree species in New York State. And I often get asked how many ash trees are in New York State, because the state wants to get an idea of how many ash trees are potentially vulnerable to the emerald ash borer. And if we take the estimated number of street trees and the statewide weighted mean, we can estimate that there are 142,000 ash trees, street trees in New York State. There's a fairly big range here as to what the number could be, and I have a feeling that if I had more data, that number would go down, but it is what it is. There's a lot of variability in the data, and it's sort of reflected in that range. So what I did for ash, I did for the most prevalent genera, and so I estimated that there were about 1.8 million maples in New York State. I can do the same thing for species, and I estimated there are approximately 864,000 Norway maples in New York State. And that's useful information to know if you have to budget for planning statewide for ash removal, for instance. I was also asked to look at the annual street tree benefits provided on a statewide basis. And okay, this number, we know how many, there's an estimate for how many street trees there are. I need to know the mean benefits per street tree. Now, as it happens, going back to Lima, we can calculate this using this software, and it's just an estimate. But the estimate was that each street tree provides $132.68 per year per tree. Now, what's interesting is that this number does not vary statewide, which is interesting because the density of plantings varies statewide, but this number does not vary statewide, so I didn't have to create a weighted statewide mean for this at all, which was nice. And when you plug that in, kicks out a number statewide annual benefits provided by street trees of approximately $556 million, which is not insignificant. And, you know, there's a 90% confidence interval as well. Additionally, because I went through a lot of data and did a lot of summary statistics, we see other things going on in the street tree population. And one of the things has to do with species diversity, and the fact that species diversity, and these are two different species diversity indices, but they both indicate that the further south we go, the more species diversity there is. And we also find that species diversity is greater for cities than for villages, and what that seems to be about is that if cities with greater financial resources typically are able to hire a city forester, and the forester is knowledgeable enough to know that species diversity is an important consideration, and therefore plants accordingly, and we see this reflected here. What we also find is that it's not sufficient statewide. And there's a 20% rule, for instance, that no one single street tree genus should exceed 20% of the population. And as we can see here, the great majority of the municipalities for which I have data exceed the 20% rule. I mean, some of these have percentages of maple between 70 and 80%, which is extraordinarily high. So bottom line, too many maples. And if we look at this graph of tree diameter, what we find is that, well, we would like to have more, we would like to have in the 0 to 6 inch range, we'd like to have more street trees in this range here to compensate for the mortality of both young and old trees. And we don't. We have the fact that this bar is right here suggests strongly that we don't have, there's not been enough planting of new trees recently, which is going to have a long-term effect on the number of trees on the streets. Also looked at sort of compared the species composition for trees in the 0 to 6 inch range to all the composition in all trees, and what you basically find is that this part's sort of good because you basically is basically suggesting that as a percentage of the population, fewer maples are being planted. But what you also see is that we're having large increases in pears and in crab apples, things like that, which is going to lead to a structural change in the street tree population over time. And that's sort of borne out by this graph, which says that larger and medium-sized trees are being planted less often than smaller-sized trees. What's very interesting is that this has power companies such as NYSEG and National Grid have made a big effort recently, in recent years, to suggest, and rightly so, that smaller sized trees should be planted under single and triple phase utility wires. And that's good. That should be done. However, if you look at whether utility wires are present or not, what you see is that irrespective of utility wires, there is a trend toward planting more smaller sized trees. And there's no graph to illustrate it here, but it's true as well with respect to planting volume. If you look at planting sites such as somebody's front lawn or yard where there's essentially no restriction on planting volume, you'll see that increasingly smaller sized trees are being planted there as well. Now, I hypothesized and found that the most explanatory power for the data I had to do with plant hardiness. In the 1990 USDA plant hardiness zones, but that isn't to say that there aren't other correlations with street tree data. There are. Median household income, annual precipitation, and type of municipality, whether it's a city, a village, or a census-designated place, does have a correlation. But what I found was that, number one, the plant hardiness zone had by far the most explanatory value, and that these variables were multicollinear with this one, so I couldn't really use it. I just tossed it out. Now that doesn't mean that if we went to another state, for instance, we went to Washington State, it could be that annual precipitation would be more significant. But in New York State, it's not. So I was asked by the DEC to take my initial findings and then go out and do some additional inventories and see how the data from those inventories compared to my initial findings. And I did 5 villages. Shortsville and Lima are in zone 6, but I had at least one from each zone, and I did intensive, street tree inventories on foot for each of these 5. They're all villages. What I found is that, is the data exactly the same? No, but basically you see very similar trends between how many trees per unit street length are planted. I mean, as you go further south, you get more trees planted per unit street length. And fewer maples as we get down to, when I went to Great Neck Plaza, which is in Nassau County, fewer maples were planted, which is what I would expect. Similarly, more oaks were planted, higher percentage of oaks. Norway maples, you see that spike up here and then goes down when you get to further south. And same with London plane tree. Now, they're not exactly the same, but I think they're reflective of the overall trends. If you look at the tree diameter profiles for the 5 villages I went to, very similar. Not enough trees in this particular 0 to 6 inch category. So I concluded that, I was on the right track, that what I did seems to be fairly accurate. And my test inventory statistics don't completely agree with my zone class level statistics, but they seem to reflect the overall trend that I found in the data. However, what's important to know, and it can't be emphasized enough, is these Great Neck Plaza and Kensington are contiguous. You can put 1 foot in Great Neck Plaza and 1 foot in Kensington. But their street tree populations are quite different, and they're somewhat different in their planting types. For instance, all the trees in Kensington are planted not in the tree lawn, but in the front lawn here, which is part of the right-of-way. So there is a lot of variability from one municipality to the next, irrespective of geographic difference. It's just the nature of the beast. So, conclusions from all this analysis. One conclusion is that we need more species diversity. We need more diversity at both the species and genus level for street trees. It's like the maple that ate all the other species here. Too many maples. Why is that important? Well, this was Hope Plaza. It was American elm, and the American elm all died because of Dutch elm disease and had to be replanted. This is Worcester, Mass. I believe these are all Norway maples. The Asian longhorn beetle really likes maples. They had an infestation of Asian longhorn beetle. They had to cut all the trees down. That's what it looks like now. If you had more species diversity, there would be less. Well, even if you had the Asian longhorn beetle, hopefully your street wouldn't be reduced to that. We need more planting of trees to at least maintain the population at a current level. Now, it's very easy to sort of call for 500,000 new trees. That's a lot of money. I don't think New York State is going to be funding 500,000 or 600,000 new street trees, because you have to think about mortality of your plantings. It's probably not going to happen anytime soon, but that's something that we need. Because larger sized trees provide more ecosystem benefits, we emphasize where planting volume is adequate and you don't have overhead wires to plant larger growing and medium-sized growing trees. That's not really being done at the moment. There's a trend towards planting smaller sized trees for whatever reason. And if we look at this data that was collected by Ohio State, where they compared the growth of Crataegus and Gleditsia, there's a tremendous difference in the amount of in the size of the tree and the leaf surface provided by the tree. And if you sort of plug this into this Forest Service program, basically the Crataegus, the honey locust, the Gleditsia, is providing roughly 8 times the amount of benefits provided by the Crataegus. It's a big difference. 8 times the amount of stormwater mitigation provided by the Gleditsia as opposed to the Crataegus. So what's going on is that we're programming a reduction in ecosystem benefits provided by street trees. Street trees are roughly 10 to 20% of the urban forest. It's not an insignificant component. And the Forest Service has spent a lot of time and a lot of energy trying to get out the message that street tree benefits are important. And the question that needs to be asked is this message being heard? And if not, how can the message be retooled so it is heard? And lastly, I was asked to use methods that could be replicated by other states. What I did, this assessment depends on having enough street tree inventory data that's broadly distributed throughout a state, which is not so easy. It's an important issue. It's hard to say. New York State has a lot of data. And also, here at Cornell, through the SWAP program, we've generated a lot of data. So it's hard to say whether other states have enough data that could be used to replicate what was done here. The other thing that's probably not as obvious is that you need data about streets, because we need to use GIS to go through the street data to do what was done here. And presumably we can do that through departments of transportation in those states. And lastly, the other thing to consider is that, in New York State, plant hardiness zone was the best predictor variable. But that not, as I mentioned before, it's not necessarily true. It may not necessarily be true in other states. And to try it in another state and see what happens. So I would like to acknowledge my committee, Nina Bassick, Peter Trowbridge, and Joe Francis. They've been extremely helpful, and I appreciate their wisdom throughout the years, and it's great to have advisors who are older than I am, which is hard. I'd like to thank the New York State Department of Environmental Conservation for providing funding. I'd also like to thank the municipalities and urban forestry companies and individuals who had the data and who provided it to me. I would be remiss if I didn't thank the Cornell Student Weekend Arborist team, who not only collected a lot of the data during the fall, but helped me over a summer or two collecting data as well. And I'd like to thank the departments of Horticulture and Landscape Architecture for putting up with me for all these years. And lastly, I'd like to thank my wife Diana and my kids, who have also put up with me for a lot of years as well. So thank you. I'll be happy to answer any questions you might have.
Questions for Fred?
It was that clear, huh?
Yeah.
Yeah.
I wonder if did you look at things on a finer scale, or was it too difficult? I'm thinking of some examples could be like street use type. You could have divided it into residential in each of the zones versus commercial versus intensive residential or something.
I definitely did look at that. And that is exactly the problem. The problem is taking data at that scale and extrapolating upwards, partly because not everybody collects data at that scale. And the data that you're talking about has to be geo-referenced, meaning each tree has to have an X and Y coordinate, so you have to know exactly where it is. Not everybody collects that data. Not everybody collects street address. So and then it has to be correlated with measures such as land use and stuff like that, which may be accurate, may not be accurate. That's another scale issue. So I think that is the way to go. But in this analysis, at this level, at this time, you know, I did do what you're talking about, but I wasn't comfortable drawing too many conclusions from what I actually analyzed. I have a reduced amount of data at the level that you're talking about. And so looking at both geographic variability and differences in land use and other variables, you know, I was sort of running out of room in terms of the data.
Didn't we, our SWOT inventories were georeferenced, but most inventories don't take GPS
Well, a
coordinates.
lot of them, yeah, it's hard, they do, but it's very uneven. And I'm kind of limited, you know, that's exactly the right question. That's a great question and something I struggle with all the time. And it's just, not everybody collects the same data in the same way at the same level. And it creates a lot of challenges. So, you know, it's frustrating because when you extrapolate to the statewide level, you're sort of not answering a lot of questions, but those are the only questions. Those are the questions I felt comfortable answering.
We have a question in Geneva.
Sure.
Yes.
Geneva?
Yeah, hi, this is Alan Lack. So our question and a comment. On the iTree model that the Forest Service developed, does that take into account the difference in ecosystem services that you get with an isolated tree versus similar tree in a forest? Because an isolated tree will intercept lateral light, and you get quite different numbers if it's isolated versus within a stand.
The short answer is yes.
Sorry?
Yeah, those programs, the iTree programs that I use, are specifically targeted to street trees. They have another program that looks at forest stands.
So this stratum was individual trees, but the Forest Service also does it on a stand basis, right?
Right.
Oh, I think we have one more.
Also, just a comment, for vineyards, we worked with Art DiGaetano in the Climate Center, and he's generated a much more high-resolution temperature climatology at the 3x3 mile scale, and that's available to, you know, potentially be a lot more high resolution than those.
No, I understand. I understand that, and Oregon State has a PRISM model, and they have 30-year normals and all that stuff. And I started off using that, and it actually, I don't think it works as well for what I was doing for whatever reason. It's also not as widely available. It's not as easy to get. It's not as easy to use. And so, you know, that's how I started off working with temperature hardiness. And I wound up going to the USDA zones as cumbersome and as clumsy and as out of date as they may be. I'd be very interested to see the updated zones and see how that affects this type of analysis.
You know, I think PRISM isn't very useful because they give you averages. This one Art can tell you what percentage of the winters fell below specific temperatures at a 5 by 5 kilometer grid scale for the whole state. So you may want to look into that. I can send you more information.
Okay, thank you.
I think we have one more.
I've got a comment, Fred. This is Martin Gaffney. I'm on the City of Geneva's Safety Committee. And I'd like to comment on the statement you made about large species no longer being in vogue. And I guess we cut our own arm off in that we do have more access to urban foresters and so on that advise us. And we're no longer even planting a large species anywhere under a wire. So right away, we're doing away half of the street trees on any one street because they're on one side of the street. So we're going to be stuck with large trees on one side and small and medium trees on the other side, which I suppose it's diverse, but it's not a very pleasing look.
Well, one thing we might want to think about is on the side of the street with the wires, not planting in the tree lawn, and maybe we plant in the front yard or lawn of the parcel, and then you could potentially plant a larger sized tree and not have the displeasing aesthetic, which is what you're talking about.
Right. Well, it's an educational thing to the homeowner to allow a tree. They tend to not fare well when a person doesn't want them in their lawn. But if we educate people and get a setback agreement that's actually signed so that the city takes care of those trees, we have had a few that have come forward and wanted a larger tree.
Well, I just think it's something that we could consider moving forward, that the traditional model of planting trees and tree lawns along the street, maybe we could rethink that a little bit, that's all.
So thanks.
Yep. Yes, Ken.
Do the utility companies exaggerate the problem of trees beneath wires, or is it costing, is it raising my utility bill?
Do utility companies exaggerate the problem of trees under wires?
We should ask the people in Connecticut. I still have, I just heard on NPR this morning that there's a call to not plant trees near wires at all in Connecticut after, people still don't have power there after the week of the snowstorm. But, I mean, there are different types of wires, and I think what Fred talked about is single and triple phase, which are the tall ones, and there's cable, the thick ones, those are cable and power, fiber optics, and they're not the ones that we're concerned about as much. It's the high ones, the single and triple phase, that is a fire hazard because they're not well insulated, and then there's also potential for stopping power if the trees come down. So I think it's a valid thing to plant trees that mature at a height of 30 feet. That's where those wires are, above 30 feet, versus having to plant really small trees. But where you don't have the height, the triple phase and the single phase, you can plant big trees. That's back in Ithaca, we do plant big trees if you just have cable and fiber optics, which are those thick wires. We'll plant right through those.
Yep.
Is there do you have a level of saturation with how many trees are feasible to even have per mile kilometer of street? And then also, can you correlate your tree diameter size with how old the street is? I'm just wondering, you say we don't have enough big or small trees to take the place of the older trees, but we have a point of saturation with some of the older trees that already have too dense of a saturation of trees to allow the smaller trees to even have a popular potential niche?
Well, you probably know more about this than I do, but yeah, you can't plant, of course you can't plant a tree every 5 feet, but you can definitely plan for newer tree. You see it all the time where you have great big old sugar maples, let's say, and younger trees getting planted between them, on the theory that on the plan looking ahead, will remove the older, possibly diseased, structurally deficient sugar maple and allow let the younger tree to get established and then remove the tree. Yeah, there are, and how on center, what the distance on center, I mean, that's kind of a question being discussed right now. I know in Syracuse is what is the proper distance between tree plantings? You know, is it better to have a greater distance or a smaller distance? But yeah, I mean, that's kind of what the Forest Service has been interested. You can't just plant it. It's great to say, yeah, we'll plant 1 million trees in New York City, but where? You know, I'm not sure if I answered your question, but did I?
Well, I'm just wondering, you know, if there's a correlation with the smaller trees, just because maybe new road construction has been, there's that correlation there, if that's the full reason why we're having this.
The smaller trees is something they've seen in California. They've seen it in many different states. I didn't make that up. It's been, and it's not unique to New York City,
New Jersey,
to New York State.
everywhere.
You know, you can speculate. I mean, to some extent, it's a function of departments of public works that usually typically maintain and plant the trees. Consider those smaller trees to be easier to maintain, and so they're more inclined to plant them. And that may be true in the short term. That's not necessarily true in the long term. They're looking at reduced maintenance costs, which is a big concern of theirs. But, you know, there's possibly also, and I thought about maybe there's just how we think of the street has changed. I mean, we're no longer such a pedestrian-oriented society. We're kind of a drive-through society. And maybe that's part of it. We don't look for the same thing from trees that we used to, but it's not unique to New York State. Is it this trend of smaller sized plantings? Yes, Tom.
Fred, did you come up with a number for the number of trees that could be planted?
No.
Given some evaluation?
No.
Okay.
No. Absolutely not.
We have those for our SWAT, our 40 SWAT cities that we've done.
That's a real scale issue.
Yeah, but we don't have it for the other places. And on a statewide basis, that's really
Yeah.
difficult to figure out.
Yeah. Okay.
Well, thanks very much, Fred.
Thank you.
This has been a production of Cornell University, on the web at cornell.edu.